Hi guys, it's nice to be with you again. We're going to identify and describe relations and functions in this session, okay? Lots of fun. What is a relation? Well, you might ask. At its most basic, ladies and gentlemen, a relation is a set of ordered pairs, x's and y's, as pairs, okay? This is pretty primitive, but this is the most basic form. For example, we've got Mr. U here. He consists of simply 4 ordered pairs of x's and y's, okay? These coordinate pairs. That's all that Mr. U consists of, and he's a relation in its most basic form. So U is a relation because there is a relationship connecting x and y. Now, it's not obvious to us what that is or might be, but there must be some kind of a relationship between x and y, otherwise you wouldn't be able to connect those x's and those y's together. X is called the independent variable, which once chosen fixes the value of y, which is the dependent variable dependent on x. That makes sense, doesn't it? This is all pretty basic stuff, so just soak it up, alright? Now, there may or may not be a specific rule connecting x and y, as I think the case is up here. Well, I can't see what it is. Now, here's an example of one where there is a rule connecting x and y. This is Mr. T. T is a relation. We've got these ordered pairs, x and y. So let's just put it all out in an English sentence. T is the set of numbers, curly brackets, the set of numbers x and y such that y is x minus 2, where x is an element of the set 1, 3, 5, 7. There should be another curly bracket there. I'll just abracadabra it just a moment. Abracadabra, and there it is, okay? This is a relation where there is a rule connecting y and x is any one of those 4 numbers, and you can work out y because it depends on x, yeah? Very simple. Alright, you can see above that U has no such rule evident, as I was saying just a moment before. If the domain, which means all the values of x which apply, is not stated, it is assumed to be all of the x values which would make sense, alright? That's pretty straightforward. And here's another one, Mr. V, okay? Mr. V is the set of numbers x and y, coordinate pairs, such that y is root x. Now, you know and I know that the only domain that makes sense for this situation here is 0 or positives, okay? Nothing negative. So that's an implied domain where x can be from 0, including 0, up. Alright? Terrific. Alright, over the screen we go. Let's try and do an example to see if we can consolidate our understanding of that theory. So in this example, example 1, we're to sketch the graph of each of the following relations and state their domain and range. And we've got 6 of them, okay? Alright, let's get going. Number A. We've got Mr. A today, hooray. And we've got the set of numbers x and y such that y is x squared plus 1. Alright, no problem. That looks pretty right to me. Good old quadratic, up, translated up by 1. And let's see, what is the domain? What do you think? Well, yes, I agree with you. It's R, and the range, what's the range? Yeah, from 1 to infinity, including the 1. Well done, 10 out of 10 for you. What about number B? We've got y is greater than or equal to x minus 1. All right, here it comes. That is the graph of y equals x minus 1, but we have to do a region, okay, greater than or equal to x minus 1, which would be that hashed area up there and including the line itself, wouldn't it? Yes? It would indeed. So now, come on, what do you think the domain is and what do you think the range is? Yeah, good. The domain is all real numbers, and the range, of course, is also all real numbers because this black graph goes forever and ever in that direction and also forever and ever in that direction as well. We're cooking along very well. Let's have a look at number C. Now, number C is a bit of an oddball. It's one of those strange relations with just a few discrete coordinate points in it. Alright, let's do it. There's our Cartesian plane. So here comes the first one. That's minus 3 and 1. Here's the next one, that's 2 and 1. And the third one is minus 1 and minus 2. And the fourth one is 2 and minus 2. So I've given you a point in every quadrant just to make it a bit more interesting, although it isn't very interesting, is it? So what did you think the domain was? Well, it's just those 4 points, isn't it? So it's minus 3, minus 2, minus 1 and 2. I know, it's pretty crazy. So what about the range? Yeah, the range is only 2 points. There are only 2 y values represented in those 4 coordinate points, okay? And they were minus 2 and 1. So that's the answer to that one, okay? Let's go over the screen now and do some more. We're going to go for Mr. D now. Let's have a good look at him. X squared plus y squared equals 4. Well, that's not too hard, is it? No, it's a circle. There it goes. Now, what do you think the domain and the range are? Of course they are. The domain is from minus 2 to 2 inclusive for x, and for the y, it's the same thing. There you go. This is a snap, isn't it? Easy stuff. What about number E now? Looks like a straight line to me. 3x minus 4y equals 1, but x is only allowed to be greater than 0. So this is a restricted domain, okay? And there she be. I worked it out for you. So it starts from there. It's got a positive gradient, but you'll notice the open dot where the x is, you see, and that is the y value when x is 0, but it's not actually included, but I just put it there for reference, yeah? And we just go in this direction with the x, and the x intercept there is 1/3 and 0. So, okay, let's figure it out. What is the domain? Well, it's from whatever, they already told us what it was. It was from 0 to infinity, not including the 0. Okay, got that? What's the y? Yeah, the y is from minus 1/4 up, not including the minus 1/4. Yeah? Jolly good show. All right, one more to go now. This one's a square rooty one. Look at it. Okay, so what are we doing? This now, can you figure out what this means? How's your transformation skills going? Well, what I would do with this, ladies and gentlemen, just to give you a bit of a heads up, I would call this the square root of minus open bracket x minus 2, close bracket. Okay, then you get a bit of a feel for what it's doing. Here it comes. There she be. Look at that. So basically, its world starts where x is 2, and it's a backwards one because it's reflected around about that line where x is 2. Okay, it's sort of like when you reflect something in the y-axis, except we're reflecting it in the axis of the line x equals 2. Okay, that's really what's going on with that. Now, what about the domain and the range? Yes, that's the domain because that's what they told us. And the range, what is the range? Yeah, it's from 0 to √2. Very nice.